Worked solutions to practice paper set 1, paper 1. Question 1, expand x bracket x plus 3. We should get x squared plus 3x. Question 2, which of these has the greatest value? If we work each of them out, 6.15 times 10 to the power 4, 1, 2, 3, 4. This number is 61,500. This number here is 61,499, so it's smaller. This number here, 6.2 times 10 to the power 3, 1, 2, 3, is 6,200, so rule that one out as well. And then this number here, 61.6 times 10 to the power 3, 1, 2, 3. If we write it out, it's 61,600, so it is the largest of the three numbers. Question 3, what is 0.12 as a fraction of 0.8? So that's 0.12 over 0.8. We're going to multiply the numerator and the denominator by 100, which gives us 12 over 80. And if we simplify this fraction, dividing the numerator and the denominator by 4, we will get 3 over 20, 3/20ths, this answer here. Question number 4. The base of a pyramid has n sides. Circle the expression for the number of faces of the pyramid. We're going to draw a quick sketch diagram of a triangular-based pyramid. You can see that the base has 1, 2, 3 sides, and there are 4 faces overall, including the base. So if a pyramid has a base with n sides, it will have n plus 1 faces. Question number 5. Work out the area of the shaded section. So the area of the square is equal to 12 multiplied by 12, which is 144 centimetres squared. Each of these circles must have a diameter of 6 centimetres and hence a radius of 3 centimetres. So the area of one circle is equal to pi multiplied by 3 squared, which is 9 pi. So the area of 4 circles is equal to 9 pi multiplied by 4, or 36 pi. The shaded area is equal to 144 minus 36 pi, which cannot be simplified. So final answer, 144 minus 36 pi centimetres squared. Question 6. Bag A contains 10 blue balls and 20 red balls. Bag B contains 8 blue balls and 12 red balls. A ball is chosen at random from each bag. Joe says it is more likely that a blue ball is chosen from bag A than bag B because there are more blue balls in bag A. Is she correct? You must show your working. So, for bag A, we know that the probability of getting a blue is equal to 10 out of 30 because there are 30 balls in total in the bag, which simplifies down to 1/3. For bag B, the probability of getting a blue is equal to 8 over 20 because there are 20 balls in total in the bag, and this simplifies down. We can write it as 2/5. So we have to compare 1/3 versus 2/5, which if we give these fractions a common denominator of 15 or 30 or 60, as long as they have a common denominator it doesn't really matter. So 1/3 is the same as 5/15, and 2/5 is the same as 6/15, which means that 2/5 is greater than 1/3, which means that Joe is incorrect. Question 7. Rob is going to drive 130 miles from Hull to Liverpool. There are road works for 25 miles of the journey. He assumes his average speed will be 50 miles per hour where there are road works and 70 miles per hour for the rest of the journey. Using his assumptions, work out his journey time. So for the part of the journey where there are roadworks, we can use the formula speed equals distance over time to calculate the time. The distance travelled in this part of the journey is 25 miles, and the speed is equal to 50 miles per hour. So the time is equal to the distance divided by the speed if we cover up the time in the formula triangle. So that's equal to 25 divided by 50, which is 0.5 hours or 30 minutes. For the non-roadwork part of the journey, the distance travelled is 130, which is the total distance, take away 25, which is 105 miles, and the speed is equal to 70 miles per hour. So the time is equal to 105 divided by 70, which we have to simplify without a calculator, as this is a non-calculator paper. So we can divide 105 by 5, which is 21. We can divide 70 by 5, which is 14, and we get 21 over 14, which simplifies further as both numerator and denominator divide by 7, giving us 3 over 2, or 1.5 hours. This means that the journey time is 0.5 plus 1.5, which is equal to 2 hours. Part B. Rob's assumptions about the average speeds are too high. How does this affect his journey time? If he actually travels at a speed which is lower than the speeds used in Part A, it will take him longer to get to his destination, so his journey time will be increased. Question 8. There are between 25 and 35 students in a class. The ratio of boys to girls is 4 to 7. How many students are in the class? 4 plus 7 is equal to 11, so the total number of students must be divisible by 11. The number of students is between 25 and 35. The only number that is a factor of 11 within that range is 33, so we have to have 33 students in total. Question 10. A ball is dropped from a height of 50 metres. After each bounce, the ball reaches 20% of its previous height. How high does it reach after the second bounce? So the ball drops down from a height of 50 metres and it hits the ground. It then rebounds and bounces up to a height of 10 metres. This is because 10% of 50 equals 5, so 20% of 50 equals 10. The ball then drops back down from 10 metres and rebounds again after bounce number 2 to a new smaller height. Now this height here is going to be 20% of 10 metres, which of course is equal to 2 metres overall. Question 11. A circle has diameter 10 centimetres, a square has side length 6 centimetres. Use calculations to show that the square will fit inside the circle without touching the edge of the circle. If the square fitted inside the circle and touched the edges of it, it would look something like this. And the diagonal of the square would be equal to the diameter of the circle, which would have to be 10 centimetres. If we look at the square, the sides are both 6 centimetres, obviously, and we draw in its diagonal, we'll call that x. We can work out x using Pythagoras' theorem as x squared, the hypotenuse, is equal to 6 squared plus 6 squared, which works out to be 72. This means that x is equal to the root of 72, which we could simplify down to 6 root 2. 6 root 2 is smaller than 10, so the square will fit inside the circle without touching the edges. Another way of explaining this is to say that x squared is equal to 72, which is smaller than 10 squared, which is of course 100. So the square will fit inside the circle without touching the edges. Question 12. What percentage of a distribution is covered by the interquartile range? The interquartile range runs from the lower quartile, which is set at 25%, all the way through to the upper quartile, which is set at 75%, which means that the distance covered between the two, or the percentage of the distribution covered between the two, is 50%. Question 13. Which of these values cannot be the cosine of an angle? If we look at the graph, and I'll draw a quick sketch here of y equals cos x, the cosine of x, the graph runs from a maximum value of 1 down to a minimum value of -1. You cannot have a cosine of an angle that is bigger than 1 or smaller than -1. So 1.5 is the answer that cannot be correct. Question 14. A motor racing circuit has length 5 5/6 of a mile. A straight section of the circuit has length 1 3/4 of a mile. What fraction of the circuit is the straight circuit? So we are trying to write the straight part of the circuit as a fraction over the total length of the circuit. So that is 1 3/4 divided by 5 5/6. We're going to convert both of these to improper or top-heavy fractions. So for the first one we get 7 over 4, and then that's being divided by 35 over 6. So to divide fractions, we simply take the reciprocal of the second fraction, I flip it over, and then multiply the two together. We can cancel down, which will simplify our work. 7 divides by 7 to make 1, 35 divides by 7 to make 5, 6 divides by 2 to make 3, and 4 divides by 2 to make 2. So our actual calculation is 1 over 2 multiplied by 3 over 5, which gives us an answer of 3/10. Question 15. In the Venn diagram, we know that the total number of farms is equal to 100. W represents farms that grow wheat, and B represents farms that grow barley. We know that 70 farms grow only wheat or only barley. 4/5 of these 70 farms grow only wheat. So the first thing we have to do is work out what 4/5 of 70 is equal to. So we know that we've got to do the calculation 4/5 multiplied by 70. We can cancel this down a little bit. 70 will divide by 5 to make 14. 5 divides by 5 to make 1, so we end up having to do 4 times 14 over 1, which is 56. So there are 56 farms which only grow wheat. 70 farms grow only wheat or only barley, so we can do 70 take away 56, which gives us 14, and that gives us the 14 farms that only grow barley, and you can see that 56 plus 14 gives us the 70 that grow wheat or only barley. Now I'm going to call this middle value here x, because the next line tells us that the number of farms that grow wheat is 3 times the number that grow barley. Now, the number of farms that grow wheat is equal to 56 plus x, and this is 3 times the number of farms that grow barley, which is x plus 14. So we can now solve an equation to find the value of x. 56 plus x is equal to 3x plus 42. Subtract x from both sides. 56 is equal to 2x plus 42. Take away 42 gives us 14 is equal to 2x, so x is equal to 7. So this tells us in the centre of the Venn diagram we have 7 farms which grow barley and wheat. If we then work out what 56 plus 14 plus 7 is, this comes to a total of 77. We know that there are 100 farms in total, so 100 take away 77 gives us the 23 farms which grow neither wheat nor barley. Question 16. Work out the values of A and B. We're going to start by expanding the brackets on the left-hand side over here. So we know that 3x plus 1 multiplied by x minus 2 is equal to 3x squared minus 6x plus x minus 2, which we can simplify down to 3x squared minus 5x minus 2. So we now know that on the left-hand side of the identity, it's an identity because there's a triple equal sign here, the left-hand side is 3x squared minus 5x minus 2. Then we've also got this plus ax plus b, which you can see just here. And that is equivalent to, on the right-hand side, 3x squared plus 8x minus 5. First thing we're going to do is subtract 3x squared from both sides, which means this will vanish and this will vanish. We're then going to add 5x to both sides, and at the same time we're going to add 2 to both sides as well. Now on the left-hand side, if we add a 5x, then this term will disappear. If we add a 2, this term will disappear, and we'll be left with ax plus b. On the right-hand side, if we add a 5x, then 8x will become 13x, and if we add 2, then negative 5 will become negative 3. Now compare the left-hand side and the right-hand side of this resulting identity. Ax plus b is equivalent to 13x minus 3, so it becomes obvious that a is the same as 13 and b is the same as negative 3. Question 17. In a game, a fair spinner has 3 sections: red, blue and yellow. Jack uses this method to work out the probability of getting 2 reds from 2 spins. He writes, there are 3 colours, so the probability of the spinner landing on red is 1/3, 1/3 plus 1/3 equals 2/3, so the probability is 2/3. Make 2 criticisms of Jack's method. The first criticism comes from here, where he says that the probability of the spinner landing on red is 1/3. You can see that the red section of the spinner is 1/4 of the total circle, so the probability of landing on red is 1/4. That's criticism number 1. The second criticism is within this calculation here, as if even if the probability of landing on red was 1/3, you would have to multiply 1/3 by 1/3 to get the probability of getting 2 reds, not add the probabilities in this particular instance. So criticism 2 is that he should have multiplied, not added, the probabilities. Question 18. Rearrange this formula to make D the subject. So first step here, we're going to multiply both sides by D plus 3. So C multiplied by D plus 3 is equal to 4 minus D. The next stage, we're going to expand the brackets on the left-hand side. So we get CD plus 3C, not C3. We write 3C equals 4, take away D. Now we're going to collect any terms that contain a D on the left-hand side. So we'll need to add D to both sides. So CD plus 3C plus D equals 4. And we're going to subtract 3C from both sides so that all the terms containing D are isolated on the left and any terms that do not contain D are on the right-hand side. So we'll now have CD plus D is equal to 4, take away 3C. We now factorise the D. So D bracket C plus 1 on the left-hand side is equal to 4, take away 3C. And to isolate the D, we then divide by C plus 1, giving us D equals 4, take away 3C over C plus 1. And making sure we write that in the answer space, D equals 4, take away 3C over C plus 1. And don't forget to write down D equals as well as the right-hand side. Question 19. A circle has equation x squared plus y squared equals a quarter. Circle the length of its radius. The equation of a circle always has the form x squared plus y squared is equal to r squared. So this number here is the square of the radius. If r squared equals 1/4, r is equal to the square root of 1/4, which can be written as the square root of 1 over the square root of 4, which is 1/2. Question 20. Which expression gives the area in centimetres squared of this triangle? Notice this is a non-right angled triangle. An angle x has been given which lies in between two sides. The area formula here is area equals 1/2 AB sine C, one of the formulae that you have to memorise, and the angle C lies trapped in between sides A and B. So the area here is 1/2 multiplied by 8 multiplied by 10 multiplied by sine x. If we simplify this, this gives us 40 sine x, i.e. this answer here. Question 21. Express 0.15 recurring as a fraction in its simplest form. Now, first thing, we're going to write out x equals 0.1555 ... The recurring symbol is only over the 5, not the 1 and the 5. Now, I'm going to multiply this by 10 so that I only have the recurring part after the decimal point, which gives me 10x equals 1.5 recurring as so. I'm also going to multiply the original x by 100, so I get 100x equals 15.555 ... I'm going to rewrite this, so we've got 100x equals 15.5 recurring, and underneath that 10x equals 1.5 recurring, and then I'm going to carry out a subtraction. You can see that when we subtract, the recurring part on the right-hand side will disappear, leaving us with 14. On the left-hand side, we will get 90x. So 90x equals 14. Dividing both sides of this mini equation by 90 gives us x equals 14 over 90, which is a fraction but not in its simplest form. Halve the numerator and the denominator to give us 7/45, the final answer. Question 22. Ellie bought a scarf and a dress. The scarf cost £4. She sold both items for a total of £26. She made 100% profit on the cost of the scarf and 30% profit on the total cost. Work out her percentage profit on the cost of the dress. Now, to calculate percentage profit, one way of doing this is to do the difference between the final and the original price of an item divided by the original price of the item multiplied by 100. So we need to know the original and the final cost of the dress, and we know neither of these things. What we do know is that the scarf cost £4 and we made 100%, or Ellie made 100% profit on the cost of the scarf. That means that she must have sold the scarf for £8, i.e. double its original value. So she sold the scarf for £8. We also know that she made 30% profit on the total cost, and that she sold both items for a total of £26. So, if the original amount, the original cost of the items is 100%, and we don't know what this original cost is, we know that the final price of the items is £26, and that represents 130% of the original amount because she made 30% profit. So this means that 130% is equal to £26. So that tells us that 1% is equal to 26 divided by 130, and 100%, i.e. the original cost of the items, would be 26 over 130 multiplied by 100. We can work out this by writing the 100 as 100 over 1 and then seeing what we can simplify. Now 130 can be divided by 10 to give us 13, and 100 can be divided by 10 to give us 10. We can then simplify further because 26 will divide by 13 to give us 2, and 13 will divide by 13 to give us 1. So this gives us £20. So the original cost of the items must have been £20. Now, we know that the scarf was sold for £8 and its original cost was £4. So we can now work out that the original cost of the dress was £20, take away £4, so £16. And we can work out that the final cost of the dress was £26, take away £8, which is £18. This means that the profit on the dress was £2. The difference between £18 and £16, so the percentage profit on the dress is equal to the difference in price, which is 2, divided by the original price of the dress, which is £16, multiplied by 100. So again, we can work out this calculation. We can simplify. 100 divided by 4 gives us 25, and 16 divided by 4 gives us 4. We can then simplify further. 2 divided by 2 gives us 1, 4 divided by 2 gives us 2, so we are left with 1/2 multiplied by 25 over 1, which is the same as 25 divided by 2, or half of 25, which is 12.5, so the final answer is 12.5%. Question 23. Work out the cube root of 8 multiplied by 5 to the power of -2. The cube root of 8 is simply equal to 2. 5 squared is equal to 25. 5 to the power of -2 is equal to 1 over 25, the negative power creating a reciprocal. So we need to take the product of 2 and 25, which gives us 2 over 25, which we have to write as a decimal. The easiest way of doing this is to multiply the denominator by 4 and the numerator, so that we then end up with 8 over 100, i.e. a denominator of 100, which makes it very easy for us to see that the answer is 0.08. Question 24. Ravi is running a charity stall using 2 bags of counters. Each bag will have 20 counters and the same number of red counters. A player will pick 1 counter at random from each bag. The player wins if both counters are red. Rav wants 9 people in every 25 to win. So the probability of winning equals 9/25, which is the probability of 2 reds. So the probability of 2 reds has to be 9 over 25. How many of the 20 counters in each bag should be red? So we have to imagine this on a tree diagram where we've got bag 1 and the counters can be red or not red. And the probability of getting a red counter is x over 20 because there are 20 counters in the bag and x is the number of reds. We then think about bag number 2. Bag number 2 is completely independent of bag number 1. The counters can either be red or not. And the probability of getting a red counter is still x over 20 because it's a completely new bag. We're not filling in the rest of the tree diagram because we're not really interested in anything else that actually happens. We're just interested in the situation in which we win, which is x over 20 and x over 20, red, red. As we're working along the branches, an AND situation, the probability of getting 2 reds is x over 20 multiplied by x over 20, and we know this probability must be equal to 9 over 25. So we can simplify this result, x squared over 400, multiplying the numerators, multiplying the denominators, which must equal 9 over 25. There are a number of different ways in which to deal with this equation. Some people will multiply the numerator and denominator on the right-hand side, so you have common denominators. We can do that. For instance, we could say 25 can be turned into 400. There are 4 25s in 100, so there must be 16 25s in 400. So we can multiply the numerator and denominator by 16. So we have x squared over 400 equals 144 over 400. This then gives us x squared equals 144 and x equals 12, i.e. there must be 12 counters in the bag. Question 25. A sequence of numbers is formed by the iterative process here, i.e. this iteration formula. Describe the sequence of numbers when a1 equals 1 and show working to justify your answer. Describe means we are going to have to use some words to explain our answer. So a2 is equal to a1 squared minus a1 using this formula. Remember, n plus 1 means the next term and an is the previous term. So this is 1 squared minus 1, which is 0. a3 is then equal to a2 squared minus a2, which is 0 squared minus 0, which is 0. So you can see from just generating these two values that each time you're going to have to substitute in 0 as the previous value, which means the entire sequence will be zeros. So describing the sequence, each term after a1, which is of course equal to 1, will be 0. Question 25, part B. Describe the sequence of numbers when a1 equals -1. Show working to justify your answer. 2 marks this time. So a2 is equal to a1 squared minus a1, being very careful because there are negative numbers here. So this is 1 plus 1, which is equal to 2. a3 is then equal to a2, which is 2 squared, take away a2. This is 4, take away 2, which is equal to 2. Now, as we've gone back to the same value, 2, as soon as we substitute this in, a4 will be 2, a5 will be 2, etc., etc. So the pattern here is that every term after a1, which is of course -1, will be 2. Question 25c. Work out the value of a2 when a1 is equal to 1 take away root 2. a2 is equal to a1 squared minus a1. This pair of brackets is absolutely essential because you are subtracting and then there is a negative here as well. So we're going to have to deal with a minus situation. Firstly, we need to expand this pair of brackets, 1 minus root 2 multiplied by 1 minus root 2, and then we're taking away a 1, which is this, and then we're taking away a minus 2, so we have a plus root 2 at the end. Expanding the set of double brackets, we get 1 minus root 2 minus root 2 plus 2, then we have this minus 1 and this plus root 2. Now, collecting our like terms, we've got a 1 plus a 2, which is a 3, take away a 1, which gives us a value of 2 overall. We've then got negative root 2 minus root 2 plus a root 2, which gives us a minus root 2, so 2 minus root 2. Question 26. A, B, C and D are points on a circle centre 0. AC is a diameter of the circle. As soon as we know that this angle here, angle ABC equals 90 degrees, as we have angle in a semicircle situation. And AT is a tangent to the circle. Work out the size of angle X and the size of angle Y. Now, there are a number of different circle theorems we can use here, and there are a number of different rules that we can use as well. Now, this chord AB creates this angle here, which is 30, and it also creates the angle up here. So angles in the same segment are equal, which means that this angle here is equal to 30 degrees. So X must equal 180 minus 90 minus 30 if we're looking at this triangle here, this right angle triangle. This gives us a value of 60 degrees for X. To then work out the value of Y, we can see that Y is the angle that lies between a tangent and a chord, and it must be equal to the angle in the alternate segment. Now, the angle in the alternate segment is created when we look at this chord here and this chord here, and they meet in this angle here. So this angle here is also Y. There are a number of different ways in which we could proceed here, but one possibility is to work out this angle here, which is equal to 108 degrees. Looking at angles on a straight line, it's next to the 72 degrees. And if we created a chord running across here, then if this is our angle at the centre, then this is our angle at the circumference. And we know that this angle here and Y together make 90 degrees. So this angle here, which I'm going to label angle CBD using the correct letters, is equal to 108 divided by 2, which is 54 degrees. So angle Y must equal 90 take away 54 degrees, which is equal to 36 degrees. Finally, don't forget to fill in the answers in the answer spaces. X is 60 degrees, Y is 36 degrees. Question 27. Write root 12 plus 15 over root 3 in the form A root B, where A and B are prime numbers. So root 12 has an obvious simplification, root 4 multiplied by root 3, i.e. 2 root 3. 15 over root 3, we clearly have to rationalise the denominator, so multiply by root 3 multiplied by root 3, giving us 15 root 3 over 3, 15 and 3 in the denominator then simplify, so we can cancel it down to 5 root 3. So the final question becomes 2 root 3 plus 5 root 3, which gives us 7 root 3. Now that is in the form a root b, where a is equal to 7 and b is equal to 3, and both are prime numbers. Question 28. Solve 5x minus y equals 5 and 2y minus x squared equals 11. It's a pair of simultaneous equations where one of the simultaneous equations has a quadratic term, this x squared, in it. The first thing we're going to do is rearrange question 1, so it's in the format y equals. So if we add y to both sides, we get 5x equals y plus 5. If we subtract 5 from both sides, we will get 5x minus 5 equals y, or y equals 5x minus 5. We're then going to substitute this into equation 2. So if we look at the format of equation 2, we've got 2y minus x squared equals 11. Now, instead of the y, we're going to replace that with what y is equal to, which is 5x take away 5. So this gives us 2 brackets 5x take away 5 minus x squared equals 11. Expanding these brackets, 10x minus 10 take away x squared equals 11. Or if we subtract 11, we'll get 10x minus 21 minus x squared equals 0. Going to multiply every term by -1, so minus 10x plus 21 plus x squared equals 0, simple change of sign trick. And then we can see this is a quadratic equation, highest power x squared, and it's equal to 0. We're just going to rearrange it so we have it in a traditional format, x squared minus 10x plus 21 equals 0. Factorising this quadratic, x minus 7, x minus 3 equals 0. So we then have either x minus 7 equals 0 or x take away 3 equals 0, giving us x equals 7 or x equals 3. We're not finished because we have to work out the matching y coordinates. Remember earlier on we rearranged the equation up here and said that y was equal to 5x take away 5. So y is equal to 5 times 7 take away 5, which is 35 take away 5, which is 30. So one answer is x equals 7 and y equals 30. And the other possibility, if we use this value here, x equals 3, y equals 5 times 3 take away 5, which is 15 take away 5, which is 10. So the other possibility is x equals 3, y equals 10. Paired up. So the answers are written as two separate pairs.